Assalamualaikum warahmatullahi wabarakatuh. Welcome to International Seminar on Sustainable Development Goals and University Social Responsibilities, collaboration opportunities between University of Lawrence, France, and Universitas Islam Malang, Indonesia. Alhamdulillah wa syukurillah wassalatu wassalamu ala rasulillah wa ala alihi washabihi wa mawalah amma ba'du. The Honorable, our distinguished speakers for today's international seminar, Professor Anneli Patrician, PhD, from University of Lorraine, France. Okay, and thank you so much also for Mrs. Ria Aniza, STMS, PhD, the postdoc students in University of Lorraine. Thank you so much for your effort, flew from France to Indonesia and coming to Unisma. The Excellency, Mr. Dr. Haji Mokhtar Data MPD, as a Bada Foundation Secretary, and also Professor Dr. Insinyur Badat Muakhid MP IPM, as the Chairman of the Foundation's Supervisory Board, and Professor Dr. Insinyur Agus Sugianto SPMP, as the Foundation's President, and also Dr. Insinyur Masyuri Mahfudz MP, as a Foundation Administrator for Education, and His Excellency Professor Dr. Analis Haji Junaidi MPD PhD, as Rector of Universitas Islam Malang, and also coming the Vice Rector 1, Dr. Haja Erna Sulistiawati MKes PhD, Vice Rector on Academic and Collaboration Affairs, and also Dr. Haji Roni Malafia Mardani SMM MUS, as a Vice Rector on General and Financial Affairs, and also a Vice Rector on Institutional Publication and Information Technology, Dr. Hasan Jadi SSC MSc. And of course, all deans, all head of bureau, vice dean, all head of department, head of international office, and ladies and gentlemen. Thank you so much for your coming to this event. And to kick off our international seminar today, let's start by reciting Quran, ala hadiniyah wa ala kullin salihah, al-Fatiha. The next agenda is singing Indonesian National Anthem, French National Anthem, and March Benar-Batan. Ladies and gentlemen, please be standing.
الوطن يلا الوطن حب الوطن من الإيمان ولا تكن من الحرمان انهضوا على الوطن يلا الوطن يلا الوطن يلا الوطن حب الوطن من الإيمان ولا تكن من الحرمان انهضوا على الوطن إندونيسيا بلادي أنت عنوان الفخامة كل من يأتيك يوما قومي هيا القاسمة كل من يأتيك يوما قومي هيا القاسمة hati wahai tanah airku, cintamu dalam imanku, jangan halangkan nasibmu, bangkitlah hai bangsaku, usapka hati wahai tanah airku, cintamu dalam imanku, jangan halangkan nasibmu, bangkitlah hai bangsaku. Indonesia negeriku, engkau panji martabatku, siapa datang mengancammu, kan binasa di bawah dulimu, siapa datang mengancammu, kan binasa di bawah dulimu.
Ladies and gentlemen, please be seated. The next is reciting Salawat Nur Anwar. Allahumma salli ala Muhammad. Allahumma salli ala Nuril Anwar وسير الأسرار وترياك الأغيار ومفتاح باب اليسار سيدنا ومولانا محمد المختار وآله الأطهار وأصحابه الأخيار عدد نعم الله وإفضاله عدد نعم الله وإفضاله. Thank you very much. Okay, ladies and gentlemen, actually Prof. Anali was wondering why when we are doing Mas Subhanallah we do this gesture. Okay, yeah, and we really appreciate just now Prof. Anali following our gesture. Thank you so much, Prof. Okay, and this is really good respect for us. And maybe the rector will explain more about that. Okay, well, the next agenda is a welcoming speech from Rector of Unisma for Professor Dr. Haji Junaidi, MPD, PhD. The time is yours.
Assalamualaikum warahmatullahi wabarakatuh. Bismillahirrahmanirrahim. Alhamdulillahirabbil alamin. La haula wala quwata illa billahil aliyyil azim. Allahumma salli wa sallim ala sayyidina Muhammad wa ala ali sayyidina Muhammad, amma ba'd. Her Excellency Professor Anali Patrician, harus membindengkan diri ya. Patrician. Yang saya hormati Ibu Ria Aniza, STMS PhD. Beliau adalah postdoctoral fellow di University of Lorraine di Prancis, di tempat Prof. Annelien mengajar. Yang terhormat Bapak Dr. Haji Muhtar Data, Sekretaris Dewan Pembina Yayasan. Yang saya hormati Bapak Profesor Agus Sugianto, the Chairman of the Unisma Foundation. Juga Prof. Badat Muwahid MP, Ketua Pengawas Yayasan. Hadir bersama kita juga dari jajaran pengurus ada Ketua Bidang Pendidikan Pak Huri Calprof. Ya. Tinggal sebentar lagi aja. Tinggal nunggu mukjizat gitu. Yang saya hormati para Vice Rectors coming with us now, Vice Rector 1, Vice Rector 2, and Vice Rector 4. Para pimpinan fakultas atau yang mewakili ketua lembaga, unit, dan tentu mahasiswa peserta cultural exchange antara Unisma dan University of Lorraine, France. Dan di University of Lorraine di Prancis, yang perguruan tingginya itu it was born in 1950s, 1500 sekian. Jadi sekarang usianya sudah berarti more than 400 years. Your university is now more than 400 years. Sementara kita more than 40 years. Nah, gitu ya. Our university was born in 1981. Now about 44 years old. Yeah. Her university more than 400 years gitu ya. Right, tetapi bagaimanapun we are flying high gitu ya untuk mengejar seperti yang sudah 400 years old gitu. Bapak dan Ibu, perguruan tinggi beliau adalah perguruan tinggi tertua memang di Prancis. Sehingga dengan usia yang sudah cukup mapan itu sudah sangat lama itu, sekarang perguruan tinggi beliau, your university is now hosting about 60,000 students, 60.000 mahasiswa. Dari 60.000 mahasiswa itu, about 20,000 students are overseas students. Ya, 20 ribuan itu mahasiswa asingnya, sehingga about 1/3. The international students are about 1/3 of the total students. Right. Nah, antara Unisma dengan University of Lorraine ini sudah ada kerjasama. Yang kerjasama ini atas bantuan Bu Ria. Kita beri aplaus dulu untuk Bu Ria. Kerjasamanya in the form of exchange students, walaupun untuk sementara ini masih we carry out it via online. So the exchange is online, in the online mode. Mudah-mudahan nanti ke depan kita akan mendesain to be offline activities. Yeah, we are going to design offline activities sehingga students from University of Lorraine will be coming to Unisma, and then our students from Unisma will also be coming there akan berangkat ke sana, embuh terbang apa selulup gitu nanti wis urusan belakangan. Yang penting sudah fly high kan gini sudah. Right. Selulup nanti. Dalam program exchange, cultural exchange programs, we have 20 students from Unisma side and 12 students from the French side, from the University of Lorraine side. So in total we have 32 students taking part in the program. Kita akan mendesain internship yang offline tadi itu, dan di samping itu Prof. Annalyn is already berjanji untuk bisa memfasilitasi Unisma untuk tergabung dalam huge project yang disponsori oleh Uni Eropa, European Union, namanya Erasmus, ya, program Erasmus. Karena program Erasmus itu perguruan tingginya, the university from Indonesia will be nominated by a university in European countries. Sehingga kalau ada perguruan tinggi di Eropa yang menominasikan perguruan tinggi di Indonesia, maka perguruan tinggi itu akan di granted the fund. Tapi tanpa ada yang menominasi dari perguruan tinggi di Eropa, maka kita tidak bisa. Beberapa kali kita sebenarnya we have tried to get the Erasmus project dengan menempel pada perguruan tinggi lain yang sudah mendapat, tetapi ternyata kita masih belum berhasil. Mudah-mudahan dengan nominating by University of Lorraine ini, then we will be successful to be a part of the Erasmus project. Dan juga beliau ini kebetulan suaminya juga seorang scientist. Your husband is also a scientist, right? And he belongs to the top 2% scientist of the world, gitu ya. 2% scientist dunia. So kita beri applause untuk beliau. Itu yang di depan suaminya, belakangnya kan katut bojone kan gitu toh. Gitulah. Gak ngerti ya. Right. Dan mudah-mudahan ini juga beliau menyatakan bahwa Prof. Annalyn will also facilitating us to have an MOU signing between Unisma and University of Lorraine in France. Mudah-mudahan dengan kerjasama itu nanti akan semakin memperlesat terbangnya Unisma menuju world class university. Once again, thank you very much for your coming. This is her first time coming to Indonesia. When she left her country, the temperature there was -5. Begitu mendarat di Surabaya, it is 35, gitu ya. Dari -5 to 35 degrees, gitu ya. Dari -40, right. 40 derajat perbedaan, sehingga from freezing to what is it? dari mendidih, dari meleleh, membeku ke mendidih, gitu ya. Tetapi she enjoys a lot to be in Indonesia, right? Karena orang Eropa mengharapkan cuaca yang seperti ini, gitu ya. So this kind of temperature is actually the best one, actually. Oke, terima kasih sekali lagi atas bantuan Bu Ria yang telah membawa Prof. Annalyn ke Unisma, dan mudah-mudahan kerjasama ini akan bisa terus berlanjut. Terima kasih pula atas dukungan Bapak-bapak pembina, pengurus dan juga pengawas dari yayasan atas support dan dukungannya selama ini. Mudah-mudahan kita terus bisa mengabdi di Unisma dengan sepenuh hati, membawa Unisma terbang melesat menuju world class university. Okay, thank you very much. Saya kira itu, that's all. Thank you. Wassalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. The next agenda is giving a token of appreciations and also certificate for the presenters. Therefore, we invite Prof. Anli, Mrs. Ria, and also Director, and also the Board of Foundations. Ya, kami undang juga pimpinan dari universitas, dari yayasan, dan juga dari rektorat serta pemateri. The first token of appreciations will be given by the Rector of Unisma for Professor Anali Petrosians, PhD. We invite also all the vice rectors to accompany the rectors. Baik Bapak Ibu, berikut adalah pemberian ini. Mohon tepuk tangan ya. Okay, give a round of applause. Okay, thank you so much. And the next will be given to Mrs. Ria Aniza ST by Bapak Mokhtar Data. Okay. Selaku Sekretaris Pembina Dewan Pembina Yayasan Unisma. Okay, please give a round of applause. The next is given certificate for the presenter by Professor Dr. Istri Agus Sugianto MP, Prof. Agus. Please kindly give certificate to Prof. Anali. Okay, please give a round of applause, ladies and gentlemen. And the next akan diberikan oleh Bapak Profesor Dr. Ismail Badat Mohid MP selaku Ketua Pengawas Yayasan kepada Ibu Ria Aniza ST MS PhD. Thank you so much. Dilanjutkan dengan foto bersama, foto session. Okay. Okay. The first will be formal. Okay. Okay. 3, 2, 1. Okay. Fly high, terbang melesat. Okay. Okay. 3, 2, 1. Okay, thank you very much. Let's get on the floor. Please turn around. Bapak Ibu mohon berputar, kita akan ambil foto dari depan. And Bapak Ibu juga teman-teman mahasiswa mohon untuk berdiri untuk kita foto bersama dengan pemateri dan juga para pimpinan Yayasan Universitas dan juga Rektorat. Oke, terbang melesat. Baik, terima kasih banyak. Dipersilakan untuk ke tempat duduk semula, Bapak Ibu. Oke, thank you so much for the support. Oke, terima kasih banyak kepada pimpinan Yayasan Unisma yang telah menghadiri undangan Internasional Seminar. Alhamdulillah, all the programs runs very well, and we are going to the main sessions, which is the International Seminar on Sustainable Development Goals and University Social Responsibilities, and will be moderated by Mr. Ahmad Farouk Al-Hikami STMSC. Okay, for your information, Bapak Ibu, Pak Farouk ya. Juga yang membantu mengkonekkan dengan Ibu Ria untuk bisa melakukan kerjasama ini. So with that further ado, we welcome Mr. Ahmad Farouk Al-Hikami STMSC. The stage is yours.
Okay, Assalamualaikum warahmatullahi wabarakatuh. Okay, good morning, distinguished guests, Professor Anneli Peterson and Dr. Ria Aniza, and also Your Excellency Bapak Rektor, Prof. Junaidi, and also the Vice Rectors coming. And good morning for all the colleagues and also lecturers, deans in the faculty in Unisma. So, Professor Anneli, thank you for coming to us and give a speech. It is my honor to welcome you all to the International Seminar on the Sustainable Development Goals and University Social Responsibilities, Collaborations Opportunities between the University of Lorraine and Unisma Malang. Oke, Bapak Ibu, saya akan memoderate dengan bahasa Inggris, izin agar memudahkan. Okay, today's topic will be Sustainable Development Goals. I think we all know that it is quite important to us. So every university is asked to drive on the sustainable development through education, research, and also community engagement. And I think Professor Anneli Peterson and Dr. Ria has been a lot of research in terms of sustainable development, and we would like to know what are the current research environment, a research project in France. And I think she had a lot of collaborations in the internationally and also a lot of experience. And this discussion, we would like to improve our knowledge in terms of sustainable development and also fostering the global collaboration. So hopefully after this seminar, we would like to have a very interactive discussion together because Professor Anneli, so we have 10 faculties in Unisma. Faculty of Science, Agriculture, Animal Husbandry, Engineering. I think those of faculty will be relating to your research in terms of the wood science and wood materials. Yeah. Okay, without further ado, I would like to introduce our speaker. So Professor Anneli Peterson, she obtained PhD from University of Nancy in the subject of mechanics and energetic. She is now full professor in process engineering and energetic, and her research area is sustainable wood materials, biomass milled pyrolysis, thermal degradation kinetics and modeling. And she is now as the head of the International Relation Development. So beliau adalah KUI-nya University of Lorraine. So I think this is very good opportunity to us to have her for collaborating more in terms of developing the sustainable development. And today's discussion, we also have the second keynote speaker. She is Dr. Ria Aniza. She obtained PhD from National Cheng Kung University, Taiwan, in the subject of energy engineering. Both of them are published a lot of papers and also cited in the very good publication. And I think these discussions will be parallel sessions. So the first keynote speakers will speak, and then we keep the questions, and we let Dr. Ria to speak the second time. And then after all, we'll have a question and discussion together. Okay, and I think without further ado, I would like to let Professor Anneli Peterson. So the time is yours. Would you prefer to? Okay, move microphone. Yeah. Yes.
Yeah. Okay. Thank you. Respectable Mr. President, respectable rectors and vice rectors, respectable dean, respectable community members, students, and all friends in the conference. So first of all, I would like to thanks for this invitation. I'm very honored to be here. I would like to tell a big thanks to Dr. Ria Aniza for this connection between our university and the Unisma University, and also to Dr. for the creation of our first common program together, an online program and for structuring very good way this first exchange. So today maybe I will introduce a little bit more about our research in our team. So we will talk about the woody biomass like source of renewable material. I will shortly present the University of Lorraine. Our president preferred to not say, we keep saying Université de Lorraine. But maybe when I speak in English, University of Lorraine is more common to say, so sorry, President. I will introduce briefly our laboratory also, and after we will talk about the wood heat treatment, our approaches, and our main findings. So, the University of Lorraine. Just a little movie with the University of Lorraine, and after we can see some cane numbers, but Mr. President told you that
We are building our knowledge and skills for our professional global future. We contribute each day to the sum of human knowledge. We have the opportunity to be entrepreneurs and invent jobs for ourselves and others. We keep everything running smoothly. We are open to the world. We have a wide cultural offer. We enjoy beautiful landscapes and we inherited a rich past. We are Université de Lorraine.
So where is situated the University of Lorraine? The University of Lorraine is in the heart of the Europe. You have Europe here, you have France here, and you have the University of Lorraine in all this area. And we are very close to Paris. Now with the fast train, you need just 19 minutes to reach the university, the Lorraine. So some main key numbers. The university was first created in 1572. It's a very old university, and there was many different faculties, engineer school, medicine school, law, etc. And in 2012, all these institutions merged to form the actual University of Lorraine. We welcomed there around 60,000 students, and around 20% of the students, it's an old number, but now maybe 20% of the students are international students for all levels, from bachelor, master, and PhD degree, yes. So I'll go faster. We have all the education area in the University of Lorraine. Science and technology, engineering school, undergraduate students, health, pharmacy, odontology, sport, law, economy, management, innovation. We have a very strong team in the innovation also. So humanity and social science, art, literature, language. So you have all the topic teach it in the University of Lorraine. With many doctoral school, all the research are grouped in doctoral school, and we have 8 doctoral school which grouping according to the area of the research. So what is the ambition of the University of Lorraine is to establish some strategic partnership with university abroad, and the objective is to build some double diploma and joint programs. Double diploma that students obtain a diploma from their country and the French country also. Mutual recognizing and validation of courses. It is important when you build some semester in abroad, some joint labs some joint research projects, and it is ongoing now, and some PhD supervised by the two countries, and joint publication also. So what about France and the Lorraine? The University of Lorraine, you saw that is situated here. The main city is Metz and Nancy, the biggest city, and our institute is situated in the south of the region, in Épinal, in a smaller city. And just some pictures about the cities. This is the city of Nancy with the Christmas market. Maybe next time we will talk about the Christmas market. And you have the square of Stanislas in Nancy. And last year it was chosen for the more beautiful place in Europe. So we are very proud of this. And sometime I hope you will discover by yourself. This is the city of Metz with a very important student city with student dorms and the university structure also, the cathedral, and you can walk over the river. It's a beautiful city also. And this is our smaller city of Épinal, a very calm city. And our institute is very close to the city center. You just need to cross the bridge and you go to the city center. And it's, oh, I didn't put picture of our institute. I'm sorry, I forgot to do that. Now I'll talk about our laboratory. This is the laboratory of research and study on wood materials. So our university, our laboratory is a multidisciplinary research laboratory. We have all the topic developed here to develop research activity on wood material. You have forest, and when wood is cut and leave the forest, it's our job there. So we work about all the transformation of the wood from the extraction of some important, interesting molecules to the production of material for building and for furniture and for building structure. And then this material, we try to prepare some sustainable material, and after use, in end of life, it can be burned to produce energy. And some of the waste from forest can be also used to produce energy by direct combustion or pyrolysis. So all that is developed in our lab, all the scales from molecule to the structure and going back to the nature like ashes. So we have around 40 academics and 40 young researchers, like PhD students, postdoctoral students, invited researchers. And we have the interface between the academic research, important to know what happened, the fundamental academic research, and the wood industry throughout some technology centers. The development of the wood treatment in our lab, and in our team especially. So we have a really international team with international collaboration. We are working for the thermal transformation of the material, of the wood. And we are specialized in biomass thermal degradation. We are working with Taiwan University for biomass pyrolysis, so they use the biomass for produce energy, with some Brazilian university, the University of Brasilia, to know more about the forest, how wood has been produced, the silviculture, etc. And when wood will leave, when tree will leave the forest to be wood now. Wood science with an American university which is contribute with the knowledge of the biopolymers of the wood. And recently, we start working with Dr. Ria Anissa, which contributes with his knowledge about the machine learning, and she really developed a new research axis, and I really hope continue working with the Indonesian institution, and Dr. Ria especially. What about the wood uses? We promotes the utilization of the wood to substitute some plastic and some other materials and to reduce the CO2 release in the environment. However, you know that wood cannot be directly used outside because of his shortcoming. One of them is the deformation, because wood can dry and uptake water again, and dry again and uptake water. And during these processes, the deformation of wood is important. So you cannot use this material, it's not stable. The other, maybe more important thing is that wood is attacked by fungi, and wood is strongly degraded by the fungi. And it is due to its hydrophobic character, and it is necessary to develop some methods to the wood preservation. And last decades in Europe, the utilization of some biocides, some chemical products is forbidden. So we need to develop some new environmentally friendly method to use the wood outside. And one of these methods is the heat treatment by mild putrefaction. This heat treatment is to keep the wood in a temperature region between 118 and 240 degrees. 240 degrees have to be a little bit high to the material. In inner atmosphere, free of oxygen, because if you grow the temperature with oxygen presence, you just will burn the wood, and you will not produce material. Yes, and the duration of these processes is between 8 and 12 hours. It's very long to the wood transformation, and it is used for utilization for outdoor and also indoor, because the color of wood starts to be close to the exotic wood, and it's important for customers. They like this color, and some luxury object also. So just a few words about the development of the heat treatment mode. The technology started to be developed very early in 1910, and several technology exists to produce. However, the main of just to produce outdoor structures and furnitures. And after use, because this is clean of chemical products wood, you can use to produce energy without release chemical products in the environment. The main technology to transform the wood in the industry is the convective oven, where you have the boards of the wood and you have an environmental gas contributing with the heat. So the heat is introduced with these hot gases without oxygen. And in the industry, the most used are the smokes. To increase temperature, you burn some oil, and you catch the smokes and introduce in the oven, and then you just make a circle, introducing the smokes again to avoid the presence of oxygen. And the other one is the superheated steam, to avoid the condensation of the steam on the wood. And the other technology is the vacuum oven. You put the wood and you extract all the air, and you lead the process under vacuum. It's important to say that to produce the heat-treated wood is environmentally friendly technique, because the heat used for the wood transformation is not really important. We will see later, but when wood starts to degrade, it releases energy. The reactions are exothermic, so you just need to keep the temperature with the insulation of the oven, and maybe some loss of the temperature, but the need of energy is really low. Much less than the drying of the wood process, for example. These processes, even if they are developed very early, you saw, they need to be improved, because in the industrial production, when you sell the boards to customers, you can obtain sometimes boards with deformation or boards attacked by fungi. Then customer is not happy, and the boards bring again. And in industry nowadays, you have around 40% of loss. So these lost boards can be burned. However, the price of to burn is not really the price of the material. So company lost many money. What is our challenge? So our challenge, first of them, is to help industrial to produce boards with guarantee quality. So we need to identify some control parameters when we can say that wood has the good qualities. We need to know how the different wood species behave in the oven, because we can see later, but according to the used wood species, the time, the duration of the process, and the temperature could be very different. So you cannot use exactly the same condition for the different wood species. With that, we need to analyze some kinetics of the progress, to build some numerical tool and give recommendation for industrial to lead the industrial process. And obviously, we need also to understand what happened from fundamental point of view and valorize our work with publications. So, you know, woody biomass can be transformed by several methods, biological, chemical, and we use the thermal conversion method. And our treatment is situated lower than the pyrolysis and gasification, and is without oxygen, and oxygen is used when we make the direct combustion to produce energy. What is our experimental approach? Our originality is that we use not powders that many other researchers. We use really big boards, like the boards used in the industry. 60 centimeters of length with 70 centimeters of large and a width of around 2.2 centimeters. It's a really industrial boards. We have this kind of oven, and this kind of oven is a very big oven. It's large like that. And here you can put 2 kilograms of wood to be treated, and we can follow the mass loss of the degradation with 1 gram of the precision. It's really exceptional. So we take some samples from the untreated wood, and after the treatment, we take some samples also to analyze what happened in the wood and to learn more about the chemical reaction occurring during the heat treatment, thermochemical reaction. So we use some methods like the fiber analysis. I don't know if you know, but wood is constituted from 3 polymers, hemicellulose, cellulose, and lignin. So we need to know what happened with the fiber in the material, the proximate analysis to know about the moisture, the volatiles, the fixed carbon, the crystallinity, it's concerning only the cellulose polymer. The color changes, because I told just before that we try to identify some parameters to guarantee the quality. So we check the quality changes also, and we check the thermal degradation like an indirect method to confirm the fiber analysis. So several types of wood were treated with this oven. Oh, I forgot to tell that the oven can work with vacuum, with nitrogen, some oxygen presence, but very low, not more than 6% of oxygen, and with the steam also. So we can use all the techniques. Obviously, in the industry, you don't work with nitrogen because you need to produce nitrogen, and you need big generators. So it's just a way to obtain some inert environment. And we treat some softwood wood and hardwood, and we check with 5 European wood species. So you have here the temperature progress. You grow to 1 dried wood, anhydrous wood, and then we grow to 170 degrees to make temperature stabilization like in the industry, and then we go to the heat treatment and we make transformation with different temperature from 200 to 240. It's important to say that for temperature lower than 180 degrees, polymers don't degrade. So we need to go upper to 180 degrees to obtain the polymer degradation for the wood preservation. And yes, it's curious to know that one experience with this oven, the duration, can you guess? What is the duration of one experience? Oh no, much more, because you saw that the duration of just of the plate of the heat treatment is 8 to 12 hours. So one experience, 1 week of work. Yes, it's very, very long, very long. You need to clean the oven, to make the blank, to make the experiments, and to cooling down the oven. And this technology is a really industrial technology. The engineer conceiving this reactor comes from the industry. And this industry burned a couple of years before because they opened the oven before the cooling process, so oxygen gets inside and all the production and the reactor burned. Oh yes. That's why it's important to know not only the heating process, but also to model the cooling down process, because you cannot really make sensors to follow the temperature. In the industrial process, it is difficult to do. Oh yeah, sorry. Then, after treatment, we characterize the color, and we characterize the mass loss. During the transformation, polymer are degraded, so the mass of the wood decreases. So we measure the mass loss, and after we put this treated wood in contact with fungi, you have a control block, you have the heat treated wood, and you put the colony of fungi inside, and you keep in favorable for fungi conditions with 20 degrees, 60% of relative humidity for 16 weeks. And it is, yes, 16 weeks, because this is the procedure to let the fungi develop. And then we take the samples again, we remove the fungi, and we measure the mass loss due to the time fungi attack. Okay? So here you can see the mass loss due to the thermodegradation and the mass loss due to the fungi attack. And you can see that when the degradation is not very important, fungi degradation is important. When the thermodegradation is between 8 and 12%, the durability of the wood, the resistance for fungi is almost total. So make connection with the color is very difficult, because you have to take the initial color and the final color, and for industry it is not so easy, because you cannot stop the process according to the color. You cannot wait all during the process also. In the industry it is not possible. We can do it with the experiments, but in the industry you saw the size of the oven, it is not possible. That's why we need to make some simulation and numerical recommendation for industrials. So you need to check, this is one part of wood, but for different wood, the degradation kinetically very different. So you need to know how wood becomes to make the modeling and to make the recommendations. So this is the main wood constituents. You have hemicellulose, cellulose, lignin, and extractives. Just to remember. So we would like to know what happened during the degradation. Yeah, it will be quick here. So we identify several stages. In the first stage, in 103 degrees, this is the procedure, we will just remove the moisture. At 170 degrees, we will remove all the extractive, the resins, things like that, instead of that. The third stage, beginning at 180 degrees, start the thermal degradation. And the last stage, this is not good for us. This is the slight carbonization, because we need to preserve the mechanical properties. First, polymer degraded during the thermal degradation are hemicelluloses. And so I will not keep more, we can discuss later, but because time is short, we try to, so the connection between the masters of the degradation and the durability is really a funding from our team. We try to analyze why wood start to be resistant to fungi. So our first hypothesis was that during the degradation, you produce some small molecules, and we thought that these small molecules are toxic for fungi. So what we did, we extract the produced small molecules, and you made impregnation for untreated wood. We put with fungi, fungi eat. So this is not the good hypothesis. The second one was the hydrophobic character, because when wood is treated, he is very hydrophobic. He stops to uptake the water and release again. He's really hydrophobic, so the deformation stops. It's good, it's important. However, dried wood, with oven dried wood, is hydrophobic also, but it's attacked from fungi. The presence of water was not the main important for fungi also. The third hypothesis was because hemicellulose disappears, so we thought that nutriment disappears, so fungi come, don't find the nutriment and don't eat. However, you have fungi for lignin degradation, and lignin left because it is not degraded. So this is not the explanation also. And recently, it was just a hypothesis till last year. We thought that the chemical structure of the polymers is modified. And last year, we can observe that during the degradation of hemicelluloses, you produce some small molecule, and this small molecule will make connection with lignin network and will modify that network of the lignin. So we could observe this phenomenon. Then fungi come to the wood, don't recognize the nutriment, don't eat. So yeah, how to model the process? We tried several models of the process, and these models are not realistic because during the, all the reactions are exothermic. So you need every time keep in mind the temperature modification. Moreover, during the degradation of hemicelluloses, for example, you will produce some small weight molecules like acetic acid or furfurols, and these molecules, it has been proven that they degrade, they contribute, they catalyze the degradation of the wood. So have many reactions, knowing that the wood composition is very different, not from one species to another, but even in the same tree. So it is, for me, it is not realistic. So we adopt a very global approach, a model used in the literature, is called de Blasi model. So we consider the raw wood that one homogeneous constituent, and when it degrades, First, it forms another solid homogeneous constituent and releases some volatiles. And when you continue the degradation, you form another final solid and you release other volatiles. I don't know if you are chemists, but we modelize this phenomena with simple one-stage reaction. It is not realistic. However, this model is simple. It is easy to identify the parameters with connection with the experiments. You have the experimental curve, you have the numerical curve, so you can adjust the parameters. And however, when you make the modeling for one oven, for one wood species, with conditions, even if you vary the temperature with the same parameter, the results are very good. So we cannot pretend that model for one oven can be applied to another oven. You need to make the model for each oven, but it's not so difficult, I think. However, we are able now to predict what happened and to make recommendations for industrials. And obviously, we try to make connection between the thermodegradation and what happened with wood polymers, making some presentation of what left in the wood according to the temperature, according to the duration of the degradation. So I'll stop my presentation here just for wood material. And Dr. Ria developed some further study when you use this wasted material after use to produce energy using numerical techniques.
Okay, very
So
good.
thank you
Big applause
for your
to
attention.
Professor Annelie Petersens. Okay, thank you so much, Professor. You can be seated here. Okay, very interesting topics, right? And I think a lot of participants would like to ask and discuss, but keep your question first, and we'll let Dr. Ria Aniza for giving her presentation in the machine learning in renewable energy. I think it also will be very interesting for us. Okay, the time is yours, Dr. Ria.
Okay, good morning, everyone. I'm so sorry that my voice little bit echoing. I got flu like a few weeks ago, but right now I'm in recovery phase. So yes, thank you for respected President of Unisma, and then the vice rectors, all the faculty members, also Mr. Imam and Mr. Farouk for this collaboration. And I also thank to Mr. Sony and who is the driver? Pak Torik, yes, Mr. Torik, to pick up us from Surabaya to Malang, arrive safely and drive us, give us like a small city tour. And in general, I thank to Unisma to give us a really great and warm hospitality. Yeah, maybe we give the small applause for Unisma. Yes. So yeah, this is my honor for today. I'm Ria Aniza. I would like to share briefly about the recent research and development of renewable energy on woody biomass feedstock and AI application. These research are developed between University of Lorraine under Professor Anneli and Professor Matthew Petrisan lab, and also National Cheng Kung University under Professor Wei Sin Chen, and also in Taiwan, and also Professor Rafael Quirino in Georgia Southern University in United States of America, and also Indonesia, myself for the postdoc fellow for this research. This is just education background briefly. So I from ITS and then get the master in Taiwan in environmental engineering, and then PhD in Taiwan as well in energy engineering. So yes, before we go for the research, we need to identify the challenge. So right now we know that the global non-renewable fossil fuel usage reported contribute around more than 35 gigaton CO2. So this why scientifically proven that non-renewable fossil fuel usage has the adverse effect or a negative effect for the humans and environment. For example, in here is health effect of pollution. Therefore, we try to use another alternative. For example, we use the renewable energy because it's more environmentally friendly and sustainable. And according to the literature, we have a lot of renewable energy from the hydro, wind, solar, biomass, geothermal, and etc. However, in 2021, the renewable energy in total is less than 30%. What does that mean? Meaning that we can explore more about how we use renewable energy for the future energy, like that way. And why we use biomass? Because biomass is renewable, abundantly available, and also does a great job on waste reduction. For the European countries, one of the potential renewable feedstock is the wood waste. Why wood waste? Because we can use it as the valuable added product as the woody biomass energy or bioenergy. Annually, 50.2 million tons of wood waste are generated across 28 AU countries. Why we use the idea of wood waste into energy? Because it's aligned with the zero waste principle idea and also aligned with the UN SDGs, especially number 7, affordable and clean energy, and 12, responsible consumption and production. So it's like circular economy, something like that way. And also the 13 one, climate action. So we try to reduce the CO2 by substitute the fossil fuel into the renewable energy. So in here, the idea is clear and the direction and the goal is clear. We want to use what we have, which is the waste, and we try to make it into valuable added product, which is the energy. And the progress, how we try to extract the woody biomass into energy, we need the transformation. We use the thermochemical conversion, which is combustion. However, if we have very uncontrollable the parameter of combustion, we will get another problem, which is the particulate matter. How to prevent another problem from the incomplete combustion? We need to control the combustion parameter. So this is the key for this research. And we know that energy and biomass, we usually identify it with the unit calorific value, heating, higher heating value, or HHV. For example, we have the water, we use the unit is liter, water in liter, like that way. But in here, how we know the quality or, the quantity of energy and biomass, we use calorific value, like that way, for the unit of the quantity of energy. However, because biomass is the complex material, simplify it only to know about the calorific value, it might not be fully representative of biomass itself. So that's why in study we try to introduce new approaches. So we add new approaches, which is bioexergy. Bioexergy is the term of biomass exergy. What the exergy? We can see in here, exergy is the thermodynamic term in the second law thermodynamic term. We can see in here the illustration. For example, we have the toothpaste. The energy is the all container, including the paste itself. And then the entropy is something that we can use anymore. And then the exergy is the actual something that we can use. In here, in bioexergy, meaning that exergy is the actual energy that we can use, like that way. For example, we eating food, and then we go to the toilet, we throw the, for example, the poop, the pee. It's the entropy, something that we can use, we cannot use. But the actual nutrient that we can absorb, we call it exergy. However, exergy plus entropy, we call it energy, like that way. And also, okay, I think it's clear. And also, we add the AI. In here, we choose the artificial neural network or ANN. Why we choose AI? We try to use this machine learning to predict what is the parameters that has more influence to our output of the research. So we will not going back and forth to do the research. For example, we know one parameter is really influenced to our output. So after that, the next research, we will not try to going circle, but we moving forward by knowing this is the parameter that give us more influence to our research, like that way. So we use the AI to facilitate us to execute the tasks, like that way. And ANN is mimicking the human nerve or human brain. So they have the structure, they have the unit or neurons, like the human brain, the nerve cell, and also they have the training method or algorithm. Like us, when we are kids, we try to speak A, B, C, D, like that way, and we try to train our brain to memorize, oh, this is A, this is B. The same thing with the ANN model of the machine learning or AI. And what machine learning is one of the type of deep learning. Deep learning is one of the type of machine learning. Machine learning is one of the type of AI. So it will not be confusing all of you. So what is the neural network? So neural network is part of the artificial intelligence or machine learning or deep learning, like that way. And ANN is, they has the algorithm. They try to take in the data or input the data, try to train themselves using that algorithm to recognize the pattern of the data that we input, and they will give us the prediction of the output, like that way. So they give us the new set of the data, which is, for example, parameters or the result of the research, like that way. And the hypothesis in here, we are clear, we have the motivation, the novelty, and we identify the gap between the recent situation and the current situation that we face. And we try to make a contribution, what is the new method, new approach that we can contribute to the science and the technology, like that. So in here, why? Because there's a lack of knowledge of understanding the related topic of technology and development of combustion renewable energy using biomass. And oh yes, in here for the foreign state, in here the point is we pointing out of bioenergy, as I mentioned before, HHV, and the other one is bioexergy, SEB. So HHV is the current unit that we use to quantify the energy within renewable energy in biomass. And SCB, specific chemical bioexergy, is the new approach that we try to introduce in the research and development. This is the experimental setup of analysis. We have the feedstock for the wood waste. We have the pathway, the conversion pathway. First, we go the physical, grinding, sieving, drying. And the other one, we go for the thermochemical pathway. In here is combustion. And the combustion is, we try to produce the heat. Not like another thermochemical conversion pathway, for example, torrefaction, we try to produce the biochar, bio-oil, something like that. But for the combustion, we specify, we want to know about what is the color, the heat that we can produce when we burn the feedstock. And four of the main idea for the research is we using TGA, thermogravimetric analysis, to know about the behavior of the mass loss of the biomass in the temperature change, and also the statistical evaluation, combustibility indexes. Why we need index? We want to know that our sample is good enough as the potential renewable energy. And the other one, we go for the application of AI. We want to know the prediction on how this sample could be potential for the next research. And before that, we go with the Taguchi orthogonal array. So before we do the research, we will design the research. This is the common way we do the research. First, we go with the design first. So we just don't, okay, I have this idea, I will go. No. So we need to make a design. In here, we call it design of experiment or DOE. There is a lot of DOE in this word, but one of my favorite is I using Taguchi orthogonal array. This is like Japanese way to conduct the research. So in Taguchi orthogonal array, we use factor, control parameters, and level, or the magnitude. For example, in here, I use the parameter or variable, which is the waste type, particle size, and heating rate. And the magnitude is the level itself, from the low to the highest one. And for the waste type, actually, we have two in here, hardwood and softwood. Hardwood, we use the beech species, and the softwood, we use the fir. And the other one, we add the wood blends. Wood blends is 50% between hardwood and softwood. So we want to know if we use hardwood, softwood, or mixture, which one is the good one for the solid renewable bioenergy. And for the statistical evaluation, mostly we use two, signal to noise ratio and also ANOVA, analysis of variance. And as you know in here, the confident, we put really high and strict confidence, which is alpha, no more than 0.05, which is we want our data is more than 95% confident. Means the error of our data that we produce is less than 5%. Like that way, we use the statistical analysis. Okay, this is the configuration of AI. We have the 3 configurations so far. Like this way. We have the neurons, we have the hidden layers, and then we have the outputs. This is the result. As we know, for the elemental analysis, for the CHONS element, N and S is really insignificant, meaning that this sample for the woody waste in European countries, for example, has no potential for the NOx and SOx production. It means that we don't contribute to the air pollution of NOx and SOx if we combust or if we burn the sample. The second one, for the proximate analysis, they has really low moisture content, which is it's really good for the solid biofuel. Because why? If we have really high moisture content, we need more energy to drying the sample to be burned for the energy production. And the other one, for the low moisture content, it's mean that energy density is increasing. And the other one is most combustibility performance is also improved. And in here we can see the volatile matter, or FM, is more than 80%, which is it's rich on volatile matter. It means that if we use another thermochemical conversion, for example, pyrolysis or torrefaction, for example, pyrolysis or gasification, it means that we have a high potential biogas and bio-oil, including in biofuel, or gas and liquid biofuel. It means that we do the analysis, we just don't do the analysis, but we analyze what is the percentage and then what is the type of the potential biofuel that we can produce with another thermochemical conversion pathway. And this is for the characterization. We know that the HHV, as I mentioned before, bioenergy and bio-RCG is really high. Compared to the previous study using mushroom log waste from Taiwan, our study has a better result. It means that our sample using woody waste is a good sample or a good feedstock to produce bioenergy in end of life of the forestry product. And the other one, for the FTAR or spectrum, in here we can see that the softwood has good hemicelluloses. In here you can see the mannose or glucomanans. They have 6 carbon, better than hardwood, which is silent 5 carbon. What does that mean? Meaning that we can see that C is one of the, carbon is one of the energy sources. In softwood they have 6 carbon, in hardwood they have 5 carbon. It means that softwood potentially has more energy than hardwood, in this case, in beech and fir. And then for the combustion behavior, we have identified for 3 zones. For the first one is moisture evaporation, the second one combustion reaction, and the ash formation. And we have like around 2 to 3 peaks in TGA analysis, right? For the first one is the thermodegradation of the light polymer, which is hemicelluloses and then cellulose and some lignin, and the rest is the cellulose and lignin, like that way, for the combustion. And this is for the index. We, for example, in here in ignition index, actually we have 4 levels, but for our sample, we have non-reactive, low reactive, to reactive level or index. What does that mean? Meaning that our sample is safe if we burn. But if our sample in red area or high reactive, it means we need to signal to the industry or to the student who doing the experiment using this kind of method that it could more flammable, means it can produce the fire hazard, like that way. However, luckily in our sample, we have like 3 levels, it means still safe. This is one of the beneficial that why we can use the indicator or the index to identify our sample in our research. And this is just for the statistical analysis. In here, we know that waste type has the highest influence, and then followed by the particle size and heating rate. Meaning that for the next research, according to the statistical evaluation, waste type is the important parameter than another parameter, like that way. And for the last one, for the AI analysis, also similar to the statistical analysis, they predict that the waste type has the most influence factor in bioenergy analysis and also bioexergy. And the other one, this is the comparison between our study with another study. In here, we can see that our model using ANN and the configuration, for example, this study is R square is almost 1, meaning that our model has the fit data, not overfitting, not underfitting. And so for yes, that the conclusion about the combustion behavior, combustibility, statistical evaluation, and AI. This is just some references. If you want to know more about our study, it's just published on December, few months ago. The title is Bioenergy and Bioexergy Analysis with the AI application on combustion recycled hardwood and softwood between Professor Chen, Professor Anneli, and Professor Rafael. It's published in Renewable Energy Journal. This is one of the good journal for the energy. Thank you for your attention. Terima kasih banyak. Merci beaucoup.
Okay, big applause to Dr. Ria. Okay, thank you, Dr. Ria, for a wonderful speech today. I think it's really interesting topics, right? I mean, recent research in the France and what we can do in Indonesia also. I think we can do more, I mean, collaborations. So, Professor Anneli, I would like to introduce our research. I mean, in Unisma, we have Dr. Ena Marlina. Bu Ena bisa berdiri? Yeah, she is the Dean of Faculty of Engineering, and she's working on biomass pyrolysis using microwave assist pyrolysis. And I think we had a project together with Dr. Ria, and we're still working on energy. We published in Energy about the plastic pyrolytic, the incorporation of the nanomaterials, and hopefully next project will add you as the co-author of our project. Okay, and also we have some of professor in agriculture, Professor Nur Hidayati, and I think she also published a lot of papers in terms of wood and forestry, and I think a lot of professor here, So before we continue, Professor, about the Q&A, I would like to share our video about the Unisma's introduction. Pak Ferry, bisa tolong ditampilkan videonya? I think just to give you a glance about our university, a little bit, yep. Okay.
baru dimanapun kalian berada. Ada kabar baik nih, kalau pendaftaran mahasiswa baru Universitas Islam Malang telah dibuka. Di Unisma, kalian bebas untuk memilih program studi sesuai dengan minat kalian. Terdapat 38 program studi yang tentunya sudah terakreditasi unggul dan juga internasional. Unisma berada di QS Top 153 ASEAN University Ranking, kampus swasta dengan akreditasi unggul dan juga kampus Nahdlatul Ulama terbaik di Indonesia. Dapatkan kemudahan belajar di Unisma melalui berbagai beasiswa unggulan. Daftarkan diri kamu melalui website Unisma, unisma.ac.id dan klik menu pendaftaran online. Atau kalian bisa datang langsung ke kampus Unisma Malang. Kami tunggu kehadiran kalian di Unisma Malang, kampus transformatif menuju universitas berkelas dunia.
Okay. Okay, thank you. So we have quite 20 minutes for discussion, Professor. I think anyone you can discuss not only the specific topics but also in terms of global sustainable development. You can ask in Bahasa so we can translate it, or you can ask in English as well. Okay, we open. Okay, one, I think two. Yeah, two. Okay. Oke, silahkan. Ya, ini mahasiswa. Oke, nama sama prodinya ya Mas ya.
Oke, Assalamualaikum warahmatullahi wabarakatuh. Saya Haras Tabaniaska dari Fakultas Economic and Business. Mungkin ini agak abstrak ya, tapi saya coba dulu.
Yeah.
As we know, the Russian and Ukrainian war is almost 3 years since it started in 2022. Give the big impact to European Union country or member in any aspect. Like one of the aspect is the energy prices and energy supplies. Because of, as I know that Russian is supplies European Union country is about like 15% or more, kayak biogasnya, fosilnya segala macam.
Yep.
Dan saya juga ngelihat apa ya, SGD ya, Sustainable Development Goals. Yang saya tanyakan adalah dari beberapa materi di atas itu apakah biomasa benar-benar bisa menggantikan fosil apa ya, oil atau gas gitu kan di dalam Uni Eropa. Yang kedua adalah apakah biomasa itu bisa menjadi sebagai renewable energy? Bahkan yang saya tahu bahkan mobil listrik segala macam Tesla atau Hyundai segala macam itu kan masih listriknya masih disuplai dengan batu bara. Itu aja. Mungkin bisa ditangkap. Terima kasih.
Mas siapa tadi?
Aska.
Mas Aska. Terima kasih Mas Aska. Okay, the next question Profesor Nur Hidayat. Tinggi.
Okay, thank you. Assalamualaikum warahmatullahi wabarakatuh. Good morning, Prof. Anneli and Miss Ria Anissa. Thank you for your presentation. It is very good and very interesting presentation. But regarding the wood waste, but unfortunately, right now Indonesia not have much wood waste because there is the forest area has been converted become oil palm plantation. So right now we have a very large oil palm plantation area, and currently the companies are facing problems related to the utilization of old oil palm trees.
Okay.
So this is the waste of oil palm stems.
Okay.
They have many oil palm trees, more than 25 years old. Can you give me more explanation regarding are there any requirement for the type of wood that can be processed using wood heat treatment technology, as you explained before? And there is the requirement of chemical composition like lignin, cellulose, for using the wood heat treatment technology. Because this is a big problem for our company in the oil palm plantation. Can the stem of old oil palm trees can convert become the other products using wood heat treatment?
Yeah.
Okay, thank you very much.
You're welcome. Terima kasih Profesor Nuridayati. Okay, one question for. Okay, one. Okay, thank you.
Thank you for the time. Let me introduce myself. My name is Zidan Ibrahim. I currently a medical student. I want to ask to Ms. Ria about computational thinking or deep learning. My research is adopt from the computational thinking to how the human thinking in development children. My question is, where does computational thinking manifest within the deep learning or machine learning? Thank you.
Okay. Okay, Professor. So there's three questions. The first question about in European energy prices, do you think that biomass can replace fossil fuel in the framework of the supply or utilization, something like that? And he also asking about recently there's a lot of electric cars in Indonesia. Almost 60 to 70% the electricity was produced from coal. Yeah, so it's a coal-fired power plant. But his question is, what do you think? I mean, your opinion about the biomass energy? Yep. 2 times.
Okay, thank you. Well, it's a more political question. I think that you cannot substitute all the fossil energy with biomass energy, because it means that you need many big areas to produce wood or produce biomass for energy, and that means that you will reduce the areas for the producing of food. Moreover, if you know about I don't know how to say in English, but the energy, the solar energy, when it comes to the earth, if it meets, I'm sorry, I don't know the English word, the cereals for, cereals are very white.
Okay.
So one of the parts of the energy will be reflected. The forests are very dark. Some part of the energy will be transformed for energy. So you will introduce other problems. Actually, about the electrical car, in France, there is really the politic to promote the electrical cars, but in France, the energy is mostly nuclear energy.
Oh, okay, nuclear.
So, yeah, comparing for Germany, for example, their electrical energy is fossil energy.
Fossil, okay.
So that's why in France, we can think that electrical car, the pollution will be less important because of the production of nuclear energy. And now we talk about the life cycle analysis, assessment. It has been proven last year that to produce an electrical car, the CO2 release is very important. However, very quickly on the first, I don't know, I don't remember, but maybe 40 to 50, 100 kilometers, you really, the curves like that, the curve of the electrical car are much more safe than the thermal car. So I just partly a response to your question, but I think I cannot do more.
Okay.
Thank
Dr.
you.
Ya, any addition about the first question? About biomass replacing the fossil fuel? Okay.
Yes. Okay.
Yeah.
So yeah, as I mentioned that that's correct what Professor Anneli mentioned, biomass cannot replace all the fossil fuel usage that we are currently use. Because as I mentioned before, for the renewable energy, we have several alternatives. We have solar, we have hydro, we have geothermal, and etc. Biomass is one of the alternative. And in our lab, why we try to use the waste or wood waste, I think it's also part of the answer of the another question. Because in, for example, France, forestry product, it's really a lot. And it's not like Indonesia. Indonesia maybe has, for example, municipal solid waste. In here we call it like sampah rumah tangga, for example, like that way. Or maybe the traditional market waste. But in France, they are clean, but they have several type of solid waste, which is the wood waste. And it's enormous. For example, after you do the construction of the building, sometimes we have the woods, which is we cannot use anymore for furniture or another thing. So how we try to handle this wood waste from the construction, we try to substitute it into the more valuable added product, for example, energy, like that way. So it means that we can say that biomass, we cannot replace everything with biomass, but we have the choice to use biomass to get the energy alternative, renewable energy, like that.
Yeah, I think it's quite.
Just to add something about the politic of how to use the biomass in France. Actually, in France, we don't cut the tree to produce energy. You just use the waste of forest biomass. I mean, when you need to clean the forest because some trees are dead or some branches are broken, things like that. There is many, and actually we create more company to produce biomass energy, but we use only the waste forest energy. We don't cut the tree to produce energy. And I discussed last time with the company to know if we are potentially able to increase, to create these new companies to produce biomass energy. So they said that actually we use only between 5 and 7% of potentially available wood waste. So in France, we can increase this biomass. However, replace all the fossil energy, I think it's optimistic.
Okay, yeah. Okay, so sudah menjawab ya. Okay. Okay, move to the next question, Professor Anneli. I think this is a good question also from Professor Nur Hidayati. Indonesia, right now, the regulations, we planting oil palm a lot because we also depending on the biodiesel to replace the diesel fuel. So do you think that the oil palm stems, any waste from the oil palm, like empty fruit bunch, anything, is it possible to use wood heat treatment for the, converting to anything valuable? Yep.
Well, this is a difficult question because of the French politic about the oil palm tree. Yes, you know. Last year there was a delegation from Indonesia trying to promote some common project with the palm
I
tree.
see. Yep.
And this is the politic of maybe France and the Europe about the preservation of the biodiversity. To respond to your question more directly, I think that yes, you can, because you use in the world many biomasses use it by torrefaction, like pre-treatment to produce biochar for future energy production. So I think these waste can be valorized, thermally valorized to produce further energy. I think yes.
Ya, menjawab Profesor ada, ya silahkan feedback.
I mean the old oil palm trees can be converted become the other products of woody, because the stem is so hard.
Oh.
Yeah,
maybe there is a requirement of the hardness of chemical composition of the wood can become using the wood heat treatment. There is a requirement for the chemical composition of wood to use this technology.
I guess that composition of tree will be somewhere close to the biomass we use. So I think our methods are realistic to the thermal conversion of the biomass of the trees. Okay. I think so. But maybe deeper analysis of the composition will highlight some other way to valorize for some interesting molecules for cosmetics or for I don't know, other way to do, but it's more chemist's way to extract and to valorize.
Okay. Yeah. Maybe Dr. Ria has any comments about the oil palm tree?
Yes. According, I add what Professor Annelies mentioned, that generally biomass is the mostly lignocellulosic material. Lignocellulosic material is the material that has three polymers that Professor Annelies mentioned. They contain hemicelluloses, cellulose, and lignin, including the stem of the palm trees, the old palm trees. What I want to add it, if we want to produce something, we need to make sure that our feedstock, what is the goal of our feedstock? We want to produce the biomaterial or bioenergy or something else. For example, for the health, for the food supplement, something else, something like that way. So first, we need to make the goal, what we want to produce first. The second one, if we already know what the goal we want to achieve, the second one is how to approach it. We need to make the preliminary test. Usually the preliminary test. In our lab, in Professor Annelies' lab, usually we do the routine, which is elemental analysis, proximate analysis. Elemental analysis is carbon, hydrogen, nitrogen, oxygen, and sulfur. And the other one, proximate analysis, volatile matter, fixed carbon, and etc. until the S formation. If we already know the preliminary test, for example, my sample, for example, the palm trees, they have a lot of carbon, less hydrogen, less nitrogen, less, for example, sulfur. It means that it can be a good for the energy because they have high C element. Carbon. But if they have another element, for example, So you can make another thing, for example, the biomaterial or so on. And the other one, if we want to make it into the health supplement, we need to make sure what the preliminary test for the health supplement, for example, like that way. For example, what is the antioxidant, blah, 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 like that way. So the thing is, first we need to make sure what is our goal. For example, okay, first I want to make the biomaterial or maybe bioenergy from the palm trees, old trees, something like that way. And then we take some part, we do the preliminary test, we check, okay, this is suitable. But if it's not suitable, we change the direction. Okay, bioenergy, maybe it's not good for the research or maybe not significant for us to contribute to the science and technology development. So we move to biomaterial. For example, biochar for the woody biomass. For example, the biochar for woody biomass more good for the fertilizer than the energy. Then we go to the fertilizer and we go deeply how the biochar, for example, influence the soil, influence the growth of the plant, something like that way. Maybe that's
ya,
my
jawab
answer.
Profesor J. Ya, terima kasih untuk dokter ya. Okay, Dr. last question about deep learning.
Yes,
Yeah.
deep learning. I think the question is how the conventional thinking could influence, right?
Yes, human thinking to influence the deep learning, right?
Like
I mean the others of conventional thinking such as sequencing or decomposing, pattern recognition, pattern abstraction, and until algorithm in deep learning. Where is the location from deep learning or conventional thinking and deep learning or machine learning?
The question is where is the deep learning occur, something like that way?
Yeah.
Okay. So this is one of the tough question because each model has each specification. For example, in artificial neural network, it's like the computer language. We make like a code, and then the code is, we make like the algorithm. What is the algorithm? Algorithm is the step by step. And then the instruction, for example, we want the integer for the result. What is the integer? Integer between 1 or 0. So there is no any comma. 0, 1, no. We cannot accept that one. So only integer, for example, like that way. So this is the algorithm. The algorithm in artificial neural network, we have a lot of algorithm, or we call it step. We have backward propagation. We have forward propagation. We have backward forward propagation. And we have another things. We have a lot of algorithm, or we call it code. So when we try to produce the code, we also input the data, so the code or the step could recognize the data. So we have the algorithm, we have the data, we input the data. So this configuration of AI with this algorithm, the step, they could recognize the data. Okay, I already have the procedure, right? For example, we make the cake. We already have the how to make the cake, like that way. That's the algorithm. The procedure how to make the cake is the algorithm itself. The training, we already have the training step. And then the ingredients is our input data. So we have a lot of ingredients. And then we input it according to the procedure or the algorithm. And the cake itself is the output data. That's the output data. And how this thing happen, it's because the AI, you know, the computer language, they have the, it's also the mathematical. If you want to more deep, you can see, for example, YouTube, there is very simple explanation how, for example, ANN recognize the data. So they have, for example, activation function. For example, there is a data coming, and then they recognize it as the 1, not 0. So they will activate it one of the algorithm, and then they will give the signal to the neuron, oh, this is good data, and then they will give you the output. And then if there is like one data, the algorithm recognize the data as the 0, not the 1, which is not good data, not this data that we want, or this data is not recognizable. They will moving backward, and then they try to analyze it again until it has like connection activated, and then they will give the signal and give you the output. So that's why I give you like very brief, but if you want to know, it's little bit complicated of AI. So when you have the data, you have the algorithm. Inside the algorithm, there is activation function mathematical model, which is if you input the data, if the data is good data, they will activate the neuron and then give you the signal and give you the output of the prediction. If your data is not good, they will still give you the signal, they give you the output, but the R square, the quality, the fit quality is really low. For example, 0.3, 0.4. But if your data input is really good, and then you put it into the model, and then they give you the signal, they give you the result, the R square, the fit quality of the model give you a good result, for example, 0.9999 something, or 1.00 something like that way. So inside, we have the algorithm. Inside the algorithm, they have the activation function, like that way. Yeah. So, okay, one of the things that really easy that we can use the AI open access. There is like AI open access, artificial neural network open access in the internet, and you can try how to move the data, and you can try how to configure, okay, which activation function that give us a better solution, and so on, like that way. And the other one, in this study, we collaborate with Professor Chen Wei-Xin from the Taiwan National Chung Kung University. So we have software, we call it Megaputer software. So it's like licensed program. So in there, we can input our configuration without giving the code. Because if we giving the code means we develop the model. What we want is we use the model. So it means that applicable, because we are not like computer science, we are different. We are the engineer, we are scientists, we want to use the application or the software. So we just need to adjust the configuration, and we try to adjust the data. For example, how many data we need, or the minimum data that we need to train the model to give us a good prediction, like that.
Impressive, yeah. Big applause to Dr. Ria. Okay, I think we have time, 15 minutes. So, yeah, Pak Imam, any question? Okay, I open 3 batch question. So 1, 2, 3. The last thing, Dr. Aas, yeah. Okay. Yeah. Yes, please.
Thank you so much, Pak Farouk and Prof. Anneli and Ibu Ria. Prof. Anneli, from my impression in relation to Sustainable Development Goal and University Social Responsibility, in your context, your research is in line with SDG, which is solving on renewable energy issue, and also trying to solve the problem on wood waste in Europe, which is very excellent in my opinion. So you are teaching, and then you are doing research, and then what you are doing is actually trying to solve the European big issue on wood waste as part of your university social responsibility as a whole project, and it also in line with big SDG goal. Can you also give us some maybe example of other SDG projects maybe ongoing at University of Lorraine as part of university social responsibility in terms of solving the global issue or nation issue or international issue? That's my first questions. Because the deans and also the lecturers coming here are coming from different faculties, from Faculty of Agriculture, Engineering, Education, and Economic and Business, and other faculties. And I do believe that from your explanation, it involving many parties, industry parties, companies, management, government leaders, and then engineering, scientists, education aspect. So kind of multidisciplinary projects, and which is very interesting because now is becoming a trend to work on multidisciplinary issues. And maybe you can give some example of the SDGs project or research project or kind of university social responsibility projects that happening at the moment at the University of Lorraine. And then my second question is about the opportunities for us from the perspective of students, the perspective of university in Indonesia, as well as from the perspective of multidisciplinary faculties. Do you think it is possible to join that SDG initiative together with France or maybe with other part of the world so that we can be part of the initiative to support the SDGs goals? I think all the faculties member here, they have the program called Community Service Project, which they go to some area, the villages, and then they collaborate with other faculties and also some industries. And maybe from that activity we can connect it with your project, because Mr. Farouk also mentioned that he has been working closely with Ibu Ria about some renewable energy issue. And of course, waste is also becoming a big issue in Indonesia, like Dr. Ria mentioned about household waste that happening in Indonesia, and also other renewable energy that can be explored to support the SDGs goals. So there are two questions from me. Thank you.
Okay, I think you can answer it first. Yeah.
Okay, I try to answer, but I think we can discuss for hours
Yeah.
about your questions. So about the multidisciplinarity of the research, yes, this is, I think it's important to have many approaches when you start to study a situation, because you cannot have all the knowledges for the process. For example, for our process, originally our process was not to valorize the waste. Our process was created in 2003 to help the industry to produce a good material for construction and for furnitures. So good materials with good color, with good mechanical properties, with good resistance for fungi. So for years we work about how to lead the process, and actually to construct the oven, to make the sensors, to follow the process, to follow chemical modification, to know how wood grows in forest, the silviculture, to know what will happen when wood will return to nature, we need many competences, many knowledges. That's why our team is, our work is teamwork. It's a teamwork. And one of we talk about the politics of the French education. Now we try to introduce some research approaches and methodology to undergraduate students. So we try to make some experiments by undergraduate students to teach them about the environmental issues, why we do that, why we will not continue with plastic, for example.
Exactly.
And what is necessary, for example, how to characterize the quality, what quality means, what is the criterion for quality, how to lead the process, what is the cost of the process, what is the environmental issue, what is the release, many things that. About the possibility, about the connection with the students, our education now try to develop some international connection with other countries, and because of grace of the COVID situation, now the tools are developed, and this is the way for us, for example, to develop some cross-culture activities. And I mean cross-culture, not only tradition, religion, architecture, but also scientific education. Our students knows about the logistics, the quality. Your students are multidisciplinary, so they find way to work together. And I forget some part of the questions.
I think it's already answered, Professor.
Okay,
yeah, I think it's very interesting. So just a little bit at Professor Anneli. I think the Sustainable Development Goals is being very important for us in terms of how to, because we are university, right? And education shall be add sustainability for the curriculum. What do you think in about that? Education should, the curriculum should add sustainability, and how to collaborate to improve the sustainability together about the sustainability issue?
I think that yes, every student should be sensibilized for the sustainability and for the environmental protection.
Environmental protection.
Yes, and when I was student, we don't care at all about the environment.
Yep.
I am I may study for engineer, for chemical engineering. So the release in the environment is okay. You just release.
Okay.
Now you cannot do that. Okay. And now we go over this kind of. We study about that, but we try to teach students about how they consume also, how they behave in the society. And I think the young generation start to be really attentive for this kind of a subject. And for example, I invite for my students, we make like a climate fresque.
Okay.
And we have some engineers from the energy company coming to us to make connection between humans' action and the environmental impact.
Yep.
And not just scare students, because if you scare students, so say, okay, it's lost, I continue like I do, like I always do, and it doesn't concern me, it concerns next generation, I don't care. But now students start to learn how can we modify our behavior to be a good citizen.
Yeah.
So it's important to sensibilize.
Yeah. So it's very
to
important.
make in the CV, I think for me it's obvious. So if it is my opinion, if you make that the CVs, that's for you it's not natural, and it must be natural. But maybe you can give that a manner to know that you know how to act.
Okay, so jadi a little bit speak to bahasa to understand. Jadi education di Perancis itu menanamkan dampak lingkungan terhadap proses pembelajarannya. Jadi ini sangat penting Bapak Ibu, terutama di bidang energi. Jadi bagaimana behavior atau kepribadian kita itu sudah sadar terhadap kesadaran lingkungan, dan ini memang harus ditanamkan pada pendidikan kita. Jadi pendidikan kita mungkin SKS-nya perlu ditambah, atau di part of credit semester need to be added about the SDG, Sustainable Development, karena because the current political issue, I think you heard about the President of America, Trump, the Paris Agreement. They lived for the country for Paris Agreement, where every countries agreed to reduce the CO2 release and to reduce the temperature. I think it's all a bit confused about the because they need to stable economy. Yeah, we also understand. Our president also, he said that we cannot replace coal-fired power plant 100%. It's impossible. So the way we do is it's also coal. It's also our business. We sell the coal to every country, to China, to Japan. But how we influence, we try to use co-firing. So we mix the biomass in the part of portion to the coal. And we are researching on this about the thermokinetics and everything with our students. And hopefully we could suggest to the company, to our PLN company, electricity company, that how much the percentage of the biomass and how the combustion performances. Yes. Yeah, something like that, Professor Anli. So we cannot say anything as academician. We try our best for our research to protect environment, but sometimes our political leaders say no. Yeah, because the economic and something is economic stability. Yeah. For the second question, I think Dr. Ena, yeah, please.
Ya, Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam.
I am Ena Marlina, a researcher from the mechanical engineering, and my research is about renewable energy, fuel, droplet combustion, and pyrolysis. I want to ask about research from Prof. Anneli and with Miss Ria. The title Biowaste Remediation and Valorization and Environmental Sustainability. What role does artificial intelligence play in optimizing biowaste remediation and valorization process?
Okay.
Then, what are the key artificial intelligence algorithm use the biowaste to bioenergy conversion, and how do they improve process efficiency? Okay. And yang terakhir, it is possible for me collaboration with Prof. Anneli, and I go to France for research. What are the conditions? Thank you.
Okay, so before you answer, Professor, so I think last question from Dr. Aas from Faculty of Agriculture. Yeah, I think it's sufficient for 10 minutes to answer, right? Okay.
Assalamualaikum warahmatullahi wabarakatuh. Thank you. My name is Aas, Prof. Anneli. I'm working with solar energy to provide healthy and environmentally friendly dried fruits and vegetables. From the explanation that both of you have done, maybe I'm wrong, but I conclude that Mbak Ria and Prof. Anneli use wood waste as the resources of bioenergy in biomass form. And you also use a combustion system to produce the bioenergy. Still, I still doubt. Maybe you can explain a little bit more to make us sure that biomass it's really clean, because so is it really clean to be used as the energy resources? Some statement states that if we use biomass as the energy resources, it will be the same, the impact to the environment with the fuel energy. So if we use it as the biomaterial energy, such as biochar, like you said before, it also will have a emission impact too. So make us sure that biomass is, especially came from the wood waste, is really clean, and it is safe energy resource for our world. And then is combustion categorized as the high energy demand or the low energy demand, especially when we work in an abundant resources? So maybe you can give us a close statement that don't worry, it is really safe and clean to use the biomass come from your research. Thank you.
Thank you, Dr. As. Okay, the first question, Professor Anneli and Dr. Ria, about what roles AI in the biomass conversion to energy, and I think Dr. Ria will answer it, right? And how to improve the efficiency. Do you think the algorithm of the AI can improve efficiency, and about possible collaboration? Okay, your time is yours.
Maybe I will try to answer about the AI, but the possible collaboration maybe with Professor Anneli, the one who know the procedure and so on. So yes, what is the key usage of AI? Why we need AI in our life, something like that way. First, we know about our cell phone. Before we use Symbian. Right now, maybe we use Android. We know that in Android, we also use AI, right? For example, face recognition, voice recognition, something like that way. That's also AI. However, how we use AI, we take one of the type of AI, we put it into our research field, how we try to use it. For example, AI, we can use it for the prediction. We also can use it for the cluster. We also can use it for the decision making. We also can use it, etc. For example, for the prediction, we do the research. We have a lot of the variables. We have a lot of the parameters. We don't know which parameter that really give us a good influence in our output. As I mentioned before, bioenergy, bioexergy. Because we have a lot of parameters, right? For example, elemental analysis, we have CHONS. And then proximate analysis, we have volatile matter and etc. a lot. We don't know which parameter that give us a good influence to give us a good output. See, we cannot do all the research only for this parameter. A lot of, for example, we have 10 parameters. We cannot do 10 research only to know which one is give us the most influence one for our output. So that's why we introduce the AI to facilitate us, to give us the prediction, the answer. Oh, this parameter give you a good result for your output. It means that for the next research or for the next, for example, decision making, okay, waste type has the most influence, hardwood, softwood, etc. However, for the heating rate has the third position. It means that for the next research, we need to make sure that our species, for example, for the wood, biomass wood, has the most influence for our output.
Our output is what? Our output is the bioenergy and bioexergy, heating, higher heating value and specific chemical bioexergy, the energy quantity and energy quality. It's influenced by the waste type, not really influenced by the heating rate. So for the next research, we don't talk about the heating rate anymore, but we explore, okay, the waste type is the most influenced parameter. The next one, because I only have beech and fir and mixture, maybe the next one, we explore more the beech, poplar, fir, any other waste type of wood. Like that way. So we don't circling our research, we moving forward. So, for example, we know about heating rate is the parameter, but it's not give us a good influence for our output, according to the statistical evaluation and the AI prediction. So, meaning that, okay, we move or we left the heating rate, and then we moving forward to know about another type of biomass. For example, wood, for example, maybe what the other plants, and then maybe the vegetables and so on. The waste type. That's one of the beneficial of the AI. For the clustering, sometimes we have a lot of biomass, woody biomass, algae biomass, and so on. We don't know which one is very good for the bioenergy. We don't know which one is very good for the biomaterial. We don't know which one is very good for the health or the food supplement. We use AI, we call it decision-making AI. So when you input the data and then you input the configuration, they will give you the answer. Oh, the macroalgae, this type, very good for the health supplement, but not recommended for the energy because the health supplement is the priority. Something like that. That's the AI, how the work. We don't need to do the research. Research is for the, after we have the AI validation and the statistical analysis, the research is like to validate our data. So we validate each other. We don't need to do research all of them because we don't have the time. So AI means that we save the time, we save the energy, we save the manpower, we save the research, we save the cost, like that way. So we have the important point in our pocket, we do the research in here. Other things that not really influence, we don't think about that because it's not significant, like that way. So that's for the AI. Impressive. And then for the collaboration, Professor Anneli.
Professor Anneli. So in the what framework we can do collaborations, Professor? In research, education, or something like that?
I think many collaboration are possible. It depends of the application. It depends of the funding. For example, the simple source for research. If a French team have funding and recruit you, you can go there and do your research according to the duration of the funding. In the other way, if you have funding and you would like to make research in a French team, you can ask and you can be accepted. If you know the French team, you can build a program together to submit when you have some call for proposal and try to advance together if, okay. For students, it's quite similar because you have different programs. So if you have a partner, you can figure out a program together, submit, and try to obtain the funding. And it is important to have the funding, but also to be useful for students. So you have to check about the common axis, common topics important for their respective diploma. And you can also have for students more easy to obtain some internship. Internship is shorter in the time. There is no credit to validate. However, the topic of the internship have to be suitable to the topic of the diploma.
Okay. So there is a lot of framework, Dr. Anna, internship, so the students can come to the France, but we have to make sure the program is suitable about the curriculum and also the credit transfer.
Yes.
Okay. And the last question, Professor Anali. So, I think it's also yes, it's clean. You say it's clean or not? Because they also contribute to CO2 emission, right?
Well, the utilization of the biomass is relatively recent. However, I think it's clean. Why? Because tree for the growing will use the CO2, and after you will cut the tree to do a material to use it after you burn it, and the produced CO2 during the life will be catch from the tree for the growing of the tree. So it is a virtuous cycle.
Yep.
Yes.
It is cycle. Carbon neutral kalau bahasa
Yes.
Indonesia.
Yes.
Need carbon neutral, right?
If you compare with the fossil
Fossil fuel, yep.
Fossil are also biomass, but biomass staying for billion years in the earth to make the transformation. So you need billion years for transform biomass to fossil product, and you burn it for a couple of minutes. So you know, in the time, the production of your fossil is very long, and the combustion is very quick. So your equilibrium is not respected.
Ya. So, jadi bedanya biomasa dengan fossil fuel adalah fossil fuel diambil dari dalam bumi. Itu pun ada biomasanya juga. Jadi tanaman-tanaman masa lalu, the old plant, jadi terkubur dalam bumi ditambang.
And other thing, why valorize the waste? If you left waste in the nature, they will decompose. And decomposing, they will release CO2. If you try to make a transformation, maybe you can use this waste, maybe you can, during the transformation, catch the gases and treat the gases with air pollution treatment, and use this waste instead of decomposition in the nature, use to produce energy or other products. For example, a couple of years before, we torrefied nuts of oil after production of the oil, the shell,
minyak kacang.
the shell, yeah. And we produced with this absorbent for water treatment.
I see.
So it's a way to just use the waste instead of leave them in the nature.
Jadi sisa dari pembakaran itu, biochar, itu bisa digunakan untuk absorb CO2 capture. Jadi all recycle, carbon netral. Jadi biomass setelah digunakan energinya, caranya digunakan untuk nangkep CO2. Itu namanya adsorbent. Kalau nggak nangkep CO2, maka CO2-nya diserap oleh tumbuhan itu sendiri. Jadi cycle. That's why biomass is clean. Tapi kalau batu bara itu diambil dari dalam bumi, hasil sisa fosil. Itu lama sekali nangkepnya, tidak equilibrium. Jadi input sama outputnya tidak sama. Gitu ya. Jadi waktu untuk kembali lagi menjadi recycle CO2-nya itu lama sekali. Itu more or less. Bu Ria ada tambahan sedikit?
Ya, nambahi sedikit. So what Professor Aneli and Mr. Farouk mentioned, I think it's completely correct. As the literature mentioned, biomass is one of the carbon neutral material. Yep. So for example, we can say like not trees, like another biomass, for example, microalgae. Microalgae also biomass, but they have the green pigment, how we call it, the green pigment,
Apa, Prof?
For the photosynthesis, chlorophyll, the chlorophyll. So the microalgae growing, for example, in the ocean, they capture the CO2 for their growth, for the photosynthesis, and then we catch the microalgae. We try to use it, for example, for the bioenergy. For example, we extract the oil, become the algal oil, and then for the waste, for example, we burn it, and then they release For example, CO2. But why we call it into CO2 or carbon neutral? Because the first they work to capture the CO2, and then the last time they release the CO2. So input equal to output. However, we extract the biodiesel. It means that's why biomass is one of the first is the carbon neutral, and the second one we get the beneficial because we extract the energy. It's different to fossil fuel. Fossil fuel didn't capture the CO2, but they keep release the CO2. So that's why some of the scientists mention that biomass is one of the carbon neutral, because okay, they capture the CO2 for their growth, for the photosynthesis, but when we try to burn it or we try to, utilize it, they release some emission, but the emission compared to their capture, we just make it into like equal, like that. That's the difference between the fossil fuel and the biomass. That's it.
Okay, excellent. Big applause to our speakers today. So I think this is the end of the discussion and the end of the seminar today. I just give a glance about the conclusion that the biomass is clean energy, and we can do with all the technique, thermal, chemical, and also biological technique, that we can produce the energy or valuable materials. And okay, maybe ending with the praying. Okay, so we praying, kita akhiri dengan bacaan wal asri dan Fatihah. Semoga acara ini berlancar, dan mungkin perlu diperhatikan bahwa SDG ini sangat penting dalam pembangunan edukasi kita. Jadi harapannya Bapak Ibu ketika menyusun kurikulum pasti ada part of sustainability, dan itu karena pada bumi kita perlu CO2 berkurang, banyak bencana dan lain sebagainya. Jadi sustainability adalah kebutuhan, bukan lagi opsi, but it's a need, our need in the future life. Oke, kita akhiri acara seminar ini dengan bacaan Ummul Quran dan wal asri. Al-Fatihah. Okay, thank you Professor Anneli Peterson, Dr. Ria for coming, and thank you for all the participants. Okay, big applause for the final close. Okay. Okay, Assalamualaikum warahmatullahi wabarakatuh.
Thank you. Thank you.
Teman-teman mahasiswa, stay di sini dulu, kita akan foto bareng dengan Prof. Anneli. Oke, spesial buat teman-teman mahasiswa yang mengikuti program International Virtual Exchange Program. Oke, terima kasih banyak kepada